Hello everyone, welcome back to my dining room. We're going to do one of the problems from the Match Pairs T-Test, Chapter 24. This is number 28, the summer school problem. I have all of the details written in up here, and we'll work from what we have here. I got the book open and my calculator. So notations, I think the number one thing here is that the form of the question is the most important. So we're saying the reason that we're going to do this one by matched pairs rather than a two-sample t-test is they're saying, does each individual student actually improve after taking this summer school class? Okay, we're not interested in does the overall class average go up. We're looking at individually, on average, how much do people improve after taking this class? And is it a significant enough improvement to continue doing the class? So that's what we're looking at here. One of the main things that gives away matched pairs versus the other type, the two sample, is are they the same number in each group? So to be matched pairs, you have to have the exact same number of entries in each group, and they have to be matched up, in this case by student. Student 1, student 2, student 3. I posted the problem on the job index question, number 27, and those were matched up by worker. And you find the difference for each worker. Did each individual worker improve? Okay, so here you really should read the book through the chapter there and look at the notation for the formula. The D with a line over it means the mean of differences. So this is the only way they would know, other than actually saying we're doing a matched pairs t-test, that that's what you're doing. Because it's the exact same formula as a one sample t-test, because really what we're doing is we're taking this one sample that we've created and doing a test on it. So it is actually the same mechanics as a one sample t-test, just the D with the line over it tells us that the numbers we're working with come from this third group that we've created by doing, in this case, August minus June, and calculating the differences. So our null hypothesis is that the average difference is going to be 0, that there was no change from before and after. Our alternate hypothesis in this case is greater than. We want to know, was there an improvement from beginning to end of the class? Okay. Students are considered representative. I've said that in part A. 6 is less than 10% of all students. And then we want to check the nearly normal condition. And to do that, we need to make a histogram. And since we are working from list 3, that's what I'm going to do the histogram of. So I'm going to hit zoom 9 here. I'm going to change the window a little bit. Didn't like that. It came out basically like this. Okay. Which is fairly symmetrical and unimodal, so we're going to say that it is nearly normal, so that's good. We can do a matched pairs t-test. These weren't too far apart. These are only apart by 1 or 2 here. So as we go forward, we're good with checking the conditions. So I did out all of the values. I'm going to do one variable stats on list 3. And I get that the mean difference is 5.33, and that the standard deviation is 7.45. Okay, so that's what we're looking at there. So to plug this in, we're going to say 5.33 minus 0 over 7.45 divided by the square root of 1, 2, 3, 4, 5, 6, 6 students. So we have 5 degrees of freedom. We use an alpha level of 5%. Should have started off with those things. And again, the reason I have a 0 here is our hypothesis is that the difference is 0. So we take our sample, the difference is from our samples, minus what we expected it to be, divided by our standard deviation. So 7.45 divided by square root of 6, 3.04. So 5.33 divided by 3.04, 1.74. For our t-score, so with 5 degrees of freedom, I'm going to look up 1.74 in the t-score chart. And I get it that it's between 5% and 10%. All right. We can do our t-test now on the calculator to get the exact value. It turns out to be 0.07. All right. So then we're going to make our conclusion. And since our p-value is greater than 0.05, we fail to reject the null hypothesis. All right, and we're going to find that it was not a significant increase between June and August for taking this class. Okay, so let's do a confidence interval as well. Let's say we do a 95% confidence interval. I'm going to say that what we're going to do is d plus or minus t star and the standard deviation divided by the square root of n. So the d with the line over it again from our sample, we're going to have 5.33 plus or minus, I'm going to look up a number in the chart, 7.45 divided by the square root of 6. All right, so in the chart, I'm going to look this up. I'm going to look at the 95% confidence column. 5 degrees of freedom, looks like 2.571. Okay. 7.45 divided by square root of 6 times 2.571. So 5.33 plus or minus 7.82. So 7.82 is bigger than 5.33. So I know that this interval is going to go from negative to positive. So negative 2.49, comma, 13.15. So I'd say we're 95% confident that the mean difference for their scores is going to be between 2.49 points below and 13.15 points above. So since we did capture 0 here, this agrees with our conclusion that there was not a significant difference in their scores from June to August because they actually could have just been the same. Okay, so we're 95% confident that the